Okay, the idea I brought for working with Julian is about brain-computing interface, or brain computing basically. And this is somehow related with different developments in neuroscience. And there is a list of 5 points that I wanted to show somehow, and some rows, but I'm gonna just go over that. We have been familiar with different developments, like for instance what is called thought controlling interfaces, which are basically devices that you can put on your head, and that's connected to your brain, and from there you can play games. So basically you can, for instance, have a ball on one side of the screen and move a ball and trying to put that ball from left to right or up and down, trying to put it inside the ball. Also, you can do some other things, like for instance sitting in the wheelchair and move your wheelchair just with your thoughts, right? So that's not necessary to use the hands or to push with your body. That's what is called thought controlling interfaces. Then there are other developments, like for instance some other devices used for communicating with the minimal conscious state patients. So those patients who are with a life support system somehow in bed for the rest of their lives, and there was at one point in which they were considered that they had no communication with the external world. But they developed some devices which again were put on the top of the heads, connected to the brain, and they interacted with the patient from outside. They were asked if they can hear, and if the answer was positive, then they were asked to think in certain animal or plants or colors, and with those thoughts they could read different parts of the brain which were highlighted or activated. Then there were 3 different unrelated developments. One of them was rat-to-rat brain communication. Basically, that was done by Duke University and some other university in Brazil. So basically, what happened there is that you have one rat living in a certain, if you want, neighborhood or living neighborhood or house, and that rat was asked to go and fetch the food. Okay, so the rat had to somehow learn which is the track or the trail to get the food, and then somehow they communicate that track that rat learned to a different rat through internet that was in Brazil. So basically, that path was transmitted through the web, and the other rat didn't have to look for the food, but it just went directly to the place where the cheese or the food was located. Another group after that made what was called human-to-rat communication. So it was a human-to-rat brain communication. So basically, one person with the thoughts somehow managed to move or to wiggle the rat tail. Right? That was the first communication between 2 different species. And later we have this human-to-human communication. Again, through the brain, there were 2 persons sat in the same campus in different offices, and one of them, with the brain, managed to move the arm. It was from a different colleague in a different department. So, all those recent developments, especially the last one, brought us to a point in which we could think brain as a sophisticated network of synapses and neurotransmitters that process information from outside world captured by our senses. Okay, so that's basically, I wanted to show you the picture, but it's not possible. So the speculation we have is whether we could exploit our brain as a platform to process information given in a conventional way. So for that, we can think first a very simple example, which is like, is it possible to somehow encode 2, let's say, binary numbers and make a binary operation, a logic operation, like 1 XOR 1, but in a way that, of course, you know which is the answer, but in the way that, okay, somehow putting these digital numbers in my brain, and I wanted to, my brain, my natural neural networks to solve that particular logic operation. Another one could be more complex tasks, but the tricky thing here is whether we could use our brain, for instance, when we are sleeping. So when I'm sleeping, some parts of my brain are working in some vital tasks, but some other parts of my brain are idle. So can I use those idle paths or those idle natural networks to solve problems? And from there there came different things that we might need to sort out. First of them is to comprehend how the brain operates, or how different circuits of our brain operate. Then whether it will be possible to make a computer-to-brain interface, but some things are already getting sorted. But from that we have two different sides, whether that interface could be an invasive interface or a non-invasive interface. We have to sort out the problems of data encoding, how to encode, in this case, the computing data into the brain format, and how to read the output of the operations. So that would be the decoding part. And another thing that we talked with Julian was how to do information storage. And from there from discussions, there were many other things that we came, for instance, with things like whether it would be possible to hire or lend evil brains for processing information. Other things like brain farming, how if it would be possible to do multi-processing units from our brains. Neuronal transplantation as well. That I think Julian mentioned something like, okay, the neurons from flies are much smaller than neurons from humans. So whether it would be possible to get the cavity of a neuron like a human and put smaller neurons there, so in order we can somehow exploit it as a thread, like you can exploit the GPU system now.
Processing units.
Yeah. Well, many other things. So probably you want to go on to the story.
Yeah, I don't want to keep us running too late because I know there's a lot of people still to talk, so I'll keep it short. But yeah, I really enjoyed all of that stuff with Herman, and also we talked to Mika as well about some things. Something that I said at the start, we have a massively parallel, thousands to thousands brain computer, and we have fabulous von Neumann machines, and we don't have a connection. Once we have a connection, I think it'll be very interesting to see what the implications of that are. And the story, what I have to do is find a story in this. And I think the implications of technology are not always obvious at the start. They're not what you think they're going to be. Like when we came up with silicon chips, privacy was not the total loss of global privacy was not an obvious implication. So I think to write an interesting story is to go past what are the obvious implications of a technology to the unexpected ones. So I'm going to try and follow that. I think that our initial idea about using the brain to process in its idle time at night, to use the massive parallel processing of a human brain to solve problems like that. I think that will only be useful for a while, because I think we will actually work out how we do this and then do it better externally. But I think what will be an interesting implication when we do that is that experiences will be transferable. As soon as we have an interface, as soon as we solve the interface problem between the human brain and any version of an external brain, any artificial brain, whether it's von Neumann type or a new parallel, processing very human type. Once you can get information out of here and put it back in again, our personal experiences will no longer be personal. There'll be no particular reason. And I think that the long-term implication of that is the evaporation of individuality. So we're going to go beyond the loss of privacy to the loss of the sense of the individual. Because I think if you learn, in the story ideas that we've been coming up with, imagining a person who gets involved in the very early days of this and then follow her for the next 50 years to take it through the whole cycle. Someone who's learning information at the start that someone else has. Say you want to learn mathematics. There's a very advanced branch of mathematics. It takes several years to learn, but someone has recorded themselves learning all that, and you can get that experience. I don't think you can just get that experience without getting all the stuff it's tangled up in. So, if you get that 3 years worth of learning, you're also going to get stuff that goes along with that. You're going to get so while you're in that mathematical mode, you're going to be attracted to the sort of people that person was attracted to while they were. You're going to be revolted by a different set of smells, you're going to be enjoy a different kind of food. You're going to have a massive blurring of personality. And what happens when your memories are also in that person and that person? And what kind of affinity groups do you end up with? What kind of what happens to our social networks when they are literally networks? They're instead of actually checking, because we modify our behavior and ourself on say Facebook to fit in with a social group that we're part of. We tone down certain aspects of ourselves, we are others. It changes our musical preferences, it changes our political expressions, it changes ourselves. And that's just when it's at that distance on the screen. So I think we will actually see an evaporation of the self, which will be frightening as we approach it, but when we get there will turn out to be we will normalize it very quickly. But I think that's where the story will lie, is finding a way to tell that story and try not to make it too dystopian, because I think we're going to be afraid of it in advance, but when it happens it'll just be, that's what it is to be human now. It's not what it was to be human then, and that'll be okay. So, anyway, that's probably enough to
okay. Good. Thank you.